Hello Nagendra. We will start. We will wait for 15 minutes. We will see if anyone other joins. Then we will start. Okay. Yes, Premnath. Hello, Premnath. Okay, we will wait for 2 more minutes. We will see if anyone other joins, then we will start.
Sir, good afternoon, sir.
Good afternoon, Prem.
Sir, one small doubt, sir.
Okay, ask.
Mm, Sir, maximum questions. How is it possible, sir? Write the exam.
Uh,
Assignment
okay,
like that, sir.
okay. What you want to ask? I am not able to understand. Uh, Hello, Prem.
Sir, 1 minute, sir.
Okay, no problem.
Hello, Ganesh.
Yeah, hello.
Nagendra here. See, I've
Yes.
been just going through your assignments. Now, assignment 2, question number 10, could you confirm whether it is correct? I was planning to put it in the discussion forum also. Assignment 2, question number 10.
Okay, you are talking about week 2 assignment for NPTEL.
Yes.
Okay, actually, I am not the one who is making the assignments.
Okay,
We are
okay.
only allowed to do live sessions for the questions which is in the assignments, but not we are able to solve only the questions which are likely to be in assignments, but we cannot solve the questions for assignments.
No, no,
Okay.
I'm not asking you to solve it. I want to know whether the thing is correct. I have a feeling it is wrong. Because in
Okay, I will.
assignment 0 also there was some issues.
Okay, I
Assignment
will.
0 also there were issues and it was clarified later. So
Okay.
similarly, I am having doubt on question number 10 of assignment 2
Okay, I have to check that because I have not checked the assignment too. Then I will be able to answer your question. Okay, Nagan. We
because it
can.
is not matching what the professor is telling in the lecture and in the presentations.
Okay, I will check it once. Wait a second. I think I have the assignment. No, it is not here. Let me check once. Yeah, Nagan, you can switch off your microphone for as of now. I am checking. Uh, so, what is the problem you are having in this question? Because to me, it is It seems right, I think.
No, because the allowances are not, I mean, all the statements according to me are wrong.
Okay. So
Because
you
the
are
first
saying,
one is,
yeah,
because the answers given are only statement 1, only statement 1 and 2, only statement 2 and 3, and only statement 1 and 3.
okay. So you are saying the options are incorrect. Okay,
Yes, same issue was there in assignment 1, assignment 0 also. Two questions came wrong.
okay. So you can put a doubt in that session
Yeah,
wherever
I'll
you,
put.
yeah, you can put that thing.
I'll do that.
Yeah,
Thank you.
no problem. Okay, so we will start. Prem, you were asking something? Hello, Prem.
No, sir.
Yeah, you were asking something, I think. No, okay. So we will start with today's session. So, first of all, my introduction. My name is Ganesh Shankar Bhandari, and I am a PMRF Research Fellow in IIT Roorkee. And I am here to take the live session on the NPTEL course Principles of Casting Technology, which is instructed by Professor PK Jha from IIT Roorkee. And we will solve some live problems in this session which will be related to your assignments, whichever you are going to solve in the NPTEL lectures. But we will not handle the questions which is in your present assignments. Okay. So other than that, you can ask anything if you want to ask. If you have any doubts, you can write it in chat box or you can directly raise your hands. So I will try to solve your doubt. Okay, so we will start with the live session. So, first of all, I will give a brief introduction to whatever you have read in your lectures. So, we will talk about the shrinkage mechanism. Okay, so we know we provide various allowances to nullify this shrinkage in our castings. Okay, we know one thing that whenever the liquid metal is going to solidify, that will shrink. So there are three different types of shrinkage are there. First is liquid shrinkage, second solidifying shrinkage, and third one is solid shrinkage. So first two shrinkage, first is liquid shrinkage and solidified shrinkage. We can handle this type of shrinkage with the help of riser. You have already know it. We can because these types of shrinkage can be fulfilled by the liquid metal amount in the during your solidification. Okay, so that can be fulfilled with the help of your riser. But when we talk about the solid shrinkage, we cannot fulfill these types of shrinks with the help of riser because these shrinkage will come after the solidification of your metal casting, which comes through the sensible heat losses. Okay, so these shrinkage we have to accommodate in our pattern type. Okay, we have to make our pattern in such a way so that these shrinkage can be nullified in your final castings. Okay, so total shrinkage will be liquid shrinkage plus solidifying shrinkage plus solid shrinkage. Okay, so you have already read about the pattern allowances in the video lectures. So we will solve some doubt problems on these those issues. Okay, so next is types of allowances. So you have read different types of allowances. First is draft allowance, shrinkage allowance, finish allowance, and wrapping allowance. So draft allowance is provided to in the pattern so that we can easily remove that pattern without eroding our metal casting. Okay, so these allowances are provided to uh, prevent the erosion of sand mold. Okay, so a draft is thus given to provide light clearance as it is lifted up because during that lifting up process that pattern can erode your mold surface, sand mold surface, and it will finally we coming into your casting design. Okay, so you will not be able to get a proper casting design. Okay, second one is shrinkage allowance. So we know all the most of the metals get shrink during that solidification process. There are some exceptions like aluminium alloy that will not shrink. That during the solidification, aluminium will the volume of aluminium casting will get increased. So in shrinkage allowance, there are two types of allowance. We talk about positive allowance and we talk about negative allowances. So in positive allowances, we talk about when the solid during the solidification, the metal is going to shrink. So we are going to provide the positive allowance. It's like if it is going to shrink by 2%, so we are going to provide the 2% of 2% dimensions positive uh, to neglify that allowance. Okay, but if we are talking about aluminium alloy, so we will go with the negative allowance. Okay, because we know that aluminium is going to uh, increase in the volume during the solidification casting. So we will give a negative allowance to our pattern. Okay. Then we come to finish allowance. The finish and accuracy achieved in the sand casting are generally poor, and therefore when the casting is functionally required to, we all know we will get a we will not get a smooth surface in sand casting. Okay, so we will to in order to uh, use that casting in different applications, we use a smooth surface and finished surface. So we will provide some positive allowance to our castings so that during machining we can finish our surface by machining, and we can get a smooth castings. Okay, so in order to neglify the effect of that machining, okay, the size change during machining process, we will provide some finish allowances to the casting so that we can easily remove the upper surface of our casting. Then comes to wrapping allowance. Before the withdrawal from the sand mold, the pattern is wrapped all around the vertical faces to enlarge the mold cavity slightly so that we can uh, remove it remove it easily. So since it enlarges the final castings made, so we will uh, consider this allowance as a negative allowance. In short, if we are trying to make a 100 castings, so we will make our pattern only for 99 Okay, because that 1 will be created during your removal of pattern by shaking it up. So this is going to be a negative allowance. So next we will talk about grain size analysis. As we know, in sand molding, we try to find out the properties of the sand. So grain size analysis is a very important thing. Uh, Someone is, I think, trying to join. Let me check. Okay,
Uh, Ganesh, could you make it big screen?
okay, I am making it. No problem. Yeah, it is visible now. Hello, Nagan. It is okay now.
It is visible, but it is not full screen. The slides are seen, um, and it's not full screen. The top this thing is displayed.
Okay, 1 second.
So while viewing here, it becomes smaller.
Okay, I will do it entire screen share. Now it is okay.
Ah, yes. Now, yes, correct.
Okay.
It's okay.
So when we talk about grain size analysis, there are when we talk about grain size analysis, we get it confused with the grain size analysis of the of that when we talk in microscopic analysis. Okay, so it is not that microscopic analysis, grain size analysis. It is only the size analysis of our sand, which we are going to prepare our sand mold. Okay, so in order to do the grain size analysis, we require different size of screens. as we can see in the as we can see here the sieve number of the pans, which is basically the mass size of the pans, and the diameter of the hole size is 4.75 mm to 0.075 mm. So we are going to put these screens in this order only. Okay, we are going to put the 4.75 mm screens at the on the upper half, upper pattern, and at the lowest bottom we will put the pen, and above that 200 mass screen will be there. So we are going to put our sand in around 100 or 200 gram sand in the sieves, and we will shake it for 10 to 15 minutes time period. After that shaking, we will take the weight of every size which is coming above the screens. Okay, and we will make a graph like this for grain size analysis. As we can see, we are it is a logarithmic graph. So we are seeing that percent fines, cumulative percent fines, and the grains, as the grain size is decreasing, so the percent fines are decreasing. Okay, so now we will come to our MCQ. We will solve some MCQ type questions with their with their one second. Okay. Sir, can you please tell about the casting technology exam pattern? Okay, we will talk about it later on, Priyadarshini. We will finish our session, then we will talk about your doubts. Okay. So, first question is, which of the following properties is required for pattern material? So, options are okay. So, which of the following properties is required for pattern material? That should be light in weight for facility in handling and working, resistant to wear and abrasion, dimensionally stable, sensitive to temperature and humidity, and able to take good surface finish. So we will talk about all the options. We will give the clarification for all the options one by one. Light in weight for facility in handling and working. It is a requirement for our pattern material because if it is heavy in weight, it will be not easy to handle. Resistant to wear and abrasion. Yes, it is definitely a property of the pattern material. Dimensionally, it should be stable. Next one is sensitive to temperature and humidity. So I think this is not a part of the pattern requirement, because if it is sensitive to temperature and humidity, if we are talking about wood pattern, so most of the times it is sensitive to temperature and humidity, and it will get swell up, and due to that swelling up, the size of the pattern will get changed, and it will affect your casting finally. Okay, so that should not be a property of sensitive uh, pattern material. Then able to take good surface finish. Yes, it is also a property of this material. So our answer should be A. It should be first, second, third, and fifth only. Okay, the sensitive to temperature and humidity is not a property of pattern material. Then we comes to second question. Which of the following are positive allowances? So any answer? If you anyone wanted to answer it, yes.
Machining allowance.
Okay, you are talking about machining allowance. It should be positive allowance. Okay, added to the casting volume.
Yes.
Okay, yeah, that should be the right answer because we are talking about adding to the casting volume. Okay, so in that contraction allowances, I think machining allowance is there. Some else allowance are there? Anything else? Okay, you can switch off your microphone. So, first is contraction allowance. As we know, when the casting is going to shrink, okay, so we are going to give contraction allowances for that purpose only. Okay, so if we are talking about a 100 casting, okay, in length, and if it is going to get shrink, okay, then there are high chances then that you are going to only get a casting of 98 or 99 depend on your metal properties. Okay, so in order to get that 100 casting, you have to provide the contraction allowances. Okay, you have to uh, provide a sufficient amount of positive allowance so that after contraction your casting size will not get affect. Okay, so contraction allowance will be there, which is going to be a positive allowance. And as Nagan told, the machining allowances are also there. That should be also a positive allowance because you need some surface to finish to get it machined. Okay, if you are going with a 102 then and you are going to finish your surface with 2 machining, then only you will be able to get a 100 casting. Okay, then comes to draft allowances. When we talk about draft allowances, we talk about negative allowances, because in the case of draft allowances, we are giving it some taper allowances like this thing, so that we can easily remove out our pattern material from that. So during that easy removal of pattern material, we are providing some extra length to our uh, casting. Okay, if it is, if we are going to make a 100 pattern, then during that draft allowance it will increase it to 102 casting shape. Okay, so that is going to be a negative allowance because we have to keep our casting material to 100 only. So we will go with the 98 allowance, 98 pattern. So after giving it draft allowance, it will convert to 100 Okay, so draft allowance will be going to be negative allowance. Okay, then the wrapping or shake allowance, it is also like draft allowance, it is also a negative allowance. So our answer should be first and second only. Okay, so contraction allowance and machining allowances are going to be the positive allowances. Yes, I think someone wants to join. Okay. Then next question. The amount of draft in draft allowance depends on. Uh, anyone wants to answer that? Okay. No one. So
I think
yeah,
intricacy of pattern,
yes, this is right. Anything else you want to add?
and I think even pattern material.
Yes, that is also right.
I didn't
I
understand what is method of molding.
that method of molding is basically in what type of mold you are going to make. You are going to make it sand casting, or you are going to make it your, we can say, wax casting, wax mold you are going to do it. So that is method of molding basically. Or you are going to in sand casting also there are different types of methods of molding, like you are going to do it with CO2 purging, or you are going to do it with binder only, or ramming, or like that. So that is basically the method of molding, so that will also affect your draft allowance. So all these three are correct options, but apart from that, all these three are correct, but apart from that, there are three more things which on which your amount of draft and draft allowance depends on. That is your size of the pattern. Second thing is depth of cavity. If the depth is more, you have to prepare your draft allowance according to that only. And last one is molding procedure. So I think method of molding and molding procedure is similar. Both are similar. So these are six things which we are going to take in consideration before going to give the draft allowance to our pattern. Okay. So come here we come to next question. Fourth one is which of the following statement is correct? So any answer?
I think C, 1 and
One and two. Okay. So any justification
uh,
for your answer if you want to give?
no, I think all three.
Okay, you are saying all three. Okay. But I think your first answer was correct, but we will see. We will go one by one. You can switch off your microphone. No problem. Which of the following statement is correct? The clay imparts the necessary bonding strength to the molding sand. That is true because we are going to add some. We can't go with the normal molding normal sand. We add some clay binders into our molding sand though so that it can impart the necessary bonding strength to our molding sand. Then second one is bonding quality of clay depends on the maximum thickness of water film it can maintain. Yes, it is also true. Whatever the water film it can maintain, that will affect your bonding quality of the clay. Then third one is molding strength is directly proportional to moisture content in the mold. So I think it is partially correct that molding strength is directly proportional to moisture content in mold. But we get generally get confused with this thing because when we talking about directly proportional to moisture content in the mold, so there is some limit regarding that. It is like 10% or 15% maximum moisture you can add into your molding sand. Okay. After that particular limit, if you are going to add the moisture content in your mold sand, that will decrease your molding strength. Okay. If you are going with 25 or 30% water, maybe, or you are going with 100% water, so it will adversely affect your molding strength. So I think this statement is not correct fully. Molding strength is not directly proportional to moisture content in mold. Okay, so our answer will be first and second only. Okay, so next one is which of the following statement is correct? Compatibility test measures the percentage decrease in height from the original constant level of loose sand, and Satter test is a measure of sand toughness, particularly the capacity of sand to withstand rough handling during pattern withdrawn. Okay, so anyone wants to answer? Okay, I will explain some things. So when we are talking about the compatibility test, okay, we talk about this type of thing. In this material, when we talk about compatibility test measurement from so decrease in height from original constant level of loose sand, we talk about this type of setup. Okay, we are going to ram our sand in a pattern or mold, and we are trying to check the up to which height we can compact the sand. Okay, so that is I think true. Compatibility test measures the percentage decrease in height from the original constant level of loose sand. Okay, so this thing is true. This is right. Then we comes to Satter test. So when we talk about Satter test, in our minds comes a thing like that we are going to throw something from a particular height. So we are going to check the strength of that material. So Satter test is a measure of sand toughness. Yes, right. Particularly the capacity of sand to withstand rough handling from during pattern bed drawn. So that will show us the strength of the material. Okay, strength of our sand mold, or during that pattern removal it is going to erode or not. So both statement I think are correct. So the answer should be both first and second. Okay, comes to next question. Which of the following statement are correct for sand reclamation of chemically bonded sands? The sand should maintain a consistently acceptable LOI value by increasing the thickness of resin coating on the sand grains. The reclamation system should promote excessive generation of fines caused by the fracturing of sand grains. Fines should be maintained at low level by removing maximum amount of it generated during the metal pouring operation and during reclamation itself. So any answer for that?
Two is wrong.
Okay, you are saying 2 is wrong.
Three is correct.
Uh, this one is correct. Okay,
One I don't know. I
okay.
don't know what is LOI.
So LOI is basically loss on ignition. LOI represents loss on ignition value. The sand should maintain a consistently acceptable LOI value by increasing the thickness of resin coating on the sand grains. So when we are going to increase the thickness of resin coating, okay, so what we are trying to do, we try to do, uh, okay, acceptable, increasing the thickness of resin coating on the sand grains. Okay, so when we are going to increase the resin coating on the thickness of sand grain, it will increase the LOI value, but we don't want that. We generally want the decrease of sand coating. Okay, we want that lowest possible resin coating should be applicable so that we can maintain a acceptable LOI value. Because whenever we are going to, it is true that resin coating will increase the LOI of the increase the LOI value of that sand, but we don't want that. We want that LOI value will be decreasing by the thickness of resin coating on the sand grains. Okay, so that will be the wrong answer. So our answer should be third only, as you say, Nagan. Uh, okay. So here comes next second question. Which of the following pattern material is evaporated during the casting process?
A, polystyrene.
Okay. So can you tell in which type of casting process we use this polystyrene material?
I think low foam casting agent. I don't know the exact name. Low foam
Yes.
casting agent.
Yes, low foam casting also. We also use this material during our wax mold also. Okay, when we go for investment casting, we go with like these types of material, polystyrene, wax materials, and something like that, so that it can be easily removed during the after that evaporation process. Okay, so when we talk about rubber, metal, and wood, it cannot be evaporated. So only this one will be the pattern material which is going to be evaporated during the casting processes. Okay, we use this polystyrene material as a binding material during that low foam casting. Okay, then next question. A small amount of carbonaceous material is sprinkled on the inner surface of mold cavity is called. That is dry sand, green sand, backing sand, or facing sand. So what we are talking about the sprinkling of sand on this surface. If this is our mold cavity, okay. So we used to sprinkle some carbonaceous material on the surface of this inner surface of mold cavity. So what that carbonaceous material sprinkling called? Any answer?
Facing sand.
You are saying facing sand. Okay. That is correct answer, because when we are talking about this dry sand, that is normal sand. Then we talk about green sand, that is before the casting, when we are before the molding process, when we are going to add some binder and something like that in that sand, then it will be called as green sand. And then we comes to backing sand, and last one is facing sand. So we sprinkle this carbonaceous material on this as a facing sand on the mold inner surface of mold cavity for the easy removal of our mold pattern. Okay, so that can we can easily remove the mold pattern, because that carbonaceous material will increase will decrease the uh, surface roughness on that particular part of the mold cavity. Okay, so we will be easily able to remove our mold. Okay, so next we comes to, which of the following statement is are not correct for pattern type? Any answer for that? Okay, so we are talking about which are not correct for pattern type. So when we talk about match plate type is convenient when small castings are to be produced in large quantities on molding machine. So this is not the correct one, because match plate pattern is generally used for the large size of castings which we cannot create in one go. We have to large complex types of castings. So that will be not be the correct options. Gated type is an improvement on the ungated pattern in which the gating system is separated from a part of 1 second, from a part of the pattern. So okay, then third one is in a split pattern, one half of the pattern is molded in drag and other half in cope. That is the right one, because when we talk about split pattern, one half will be in our cope, one half will be in the drag pattern. Then we comes to match plate type pattern. Type is convenient when small casting are to be produced in large quantities on molding machine. That is right. So that will be the wrong one. Which of the following statement is are not correct for pattern type? So our answer will be B, second only. Okay. Then we comes to next one. Consider the following statement. The difficulty of feeding a given alloy in a mold is expressed by a quantity that is called center line feeding resistance. Feeding is considered to be comparatively difficult if CFR value is higher. Okay. In case of pure metal, the thickness of skin frozen in any given varies with square root of the section thickness. Which of the above statement is or correct? So any answer for that? Okay, so for discussing this question, we will first talk about center line feeding resistance. So, what is center line feeding resistance? Okay, first thing is the difficulty of feeding a given alloy in a mold is expressed by a quantity that is called as center line feeding resistance. So when we talk about center line feeding resistance, okay, so that is our mold phase. Okay, when we are talking about a mold, and that will be going to be our center line of the mold. Okay, so if it is like this, that will be the center line of the feeding center line of the mold, and this will be going to be our mold phase. So when we are going to pour the liquid material into the mold, okay, so as we know, on the mold phase it will start freezing instantly, okay, because it is getting some that will be the heterogeneous cooling process, because it is getting some foreign surface for getting cooled. Okay, the heat transfer will be the highest at this point with the mold wall, and from when we are going towards the mold phase to the center line of the that point center line of that mold, so that will be our start of freezing point. When we talk about time, it will start in, maybe we can say, in 10 seconds, if it will start at 10 seconds. Okay, at 10 seconds. So but at the center line the start of freezing will be around at 20 seconds. Okay, so this difference is due to the rate of heat transfer, because at center line the rate of heat transfer will be the minimum. Okay, so when we talk about the solidification, we talk about two things. First is liquid cooling start, and then cooling end. So when we talk about liquid solidification start term, and we talk about solidification end term, so on mold phase the solidification will end earlier as compared to the center line. So this difference between the difference between the time of this mold phase to that center line phase, okay, that will be known as center line feeding resistance, CFR. So the difficulty of feeding a given alloy in a mold is expressed by a quantity called center line feeding resistance, because if this CFR is high, this is directly proportional to your solidification time. Okay, if this CFR is high, you have to provide a riser system so that you can compensate the liquid shrinkage. Okay, because that will create if CFR is high, that will create more liquid shrinkage. Okay, so you have to provide riser, you have to provide some additional changes in your mold so that CFR should be low. Okay, so this one is correct. Then feeding is considered to be comparatively difficult if CFR value is higher. That is true. In case of pure metal, the thickness of skin frozen in any given time varies with square root of the section thickness. So this is basically directly, we know equation tau equal to C root T. So when we talk about this equation, we can correlate this term, this statement with this equation, tau equal to C root T. So this is going to be correct one. So the answer will be first, second, and third. Okay. So comes to next question. The permeability of molding sand was determined using a standard AFS sample by passing 2000 cc of 2000 cubic centimeter of dimensions are given at a gauge pressure of 10 gram per cc. If the time taken for the air to escape was 1 minute, the permeability number is. So we have to calculate permeability number, PMN. For that we have a formulation. So anyone try to solve it? We have 2 minutes. You can try to solve it, and you can tell me the answer. So anyone got the answer? No? Okay, someone wants to say something. Okay, so we will see. It's basically a direct equation based question. So the permeability number formulation for permeability number is V into H, that V is your volume, H is height of the mold, then rho is density, or we can say that gauge pressure, uh, then A is area, and T is your time. So the unit for these things will be permeability. V should be in centimeter cube, density or that pressure gauge, whatever we are talking about, gauge pressure, that is gram per cc. The time taken for the air to escape will be in minute, and the area will be in centimeter square. So just we have to put the values whatever we are having. We have the we can calculate the volume of the mold, because that is we have given the height and we have given the diameter. So it would be a cylindrical mold. So we can calculate the volume of the mold. We have the height of the mold 5.05 centimeter. Then we have the gauge pressure 10 gram per cc. We can calculate the area of the mold, and we have the time to for the escaping of air for 1 minute. So we just have to put all things together, and we can get the answer as 50.10. Okay. So next one is desired characteristic of core and core sands are: cores must have sufficient hardness as well as strength in both dry and green state. Cores must be permeable to allow the core gases to escape easily. Cores should be able to withstand the high temperature of molten metal. So anyone wants to answer that?
All three are correct.
Okay. So all three are correct. Core must have sufficient hardness as well as so what is core? Basically, when we talk about core material, it should be like, in simple way, when we are talking about a cylindrical casting and we are talking about a hollow cylindrical casting, so it should be like that. This is a hollow portion of that cylindrical casting, so we have to provide a core material so that liquid material do not enter in this side. Okay, so this is going to be our core material. Okay, the cores must have sufficient hardness as well as strength in both dry and green state. Yes, it is true. Cores must be permeable to allow the core gases to escape easily, because uh, during the core making we are going to add some binders or something, like some materials which are going to provide the strength to this core. But when this core is getting in the contact with the liquid metal, so it is going to get heat, and that material whichever we are going to use as a binder material, so it is going to be escape in a volatile gaseous form. Okay, so the core must be permeable to allow the core gases to escape easily, so that those core gases must be be uh, allowed to be go from here easily. uh, the core should be able to withstand the high temperature of the molten metal. So we have to make the core either with the sand, or if the molding temperature is on the lower side, we can go with the core of some metal also. As if we talk about the copper castings, so we can make the core material with the help of mild steels also, because copper has a melting point of 1084 degrees Celsius, and the superheat temperature will be around 1200 degrees Celsius. But the mild steel has a melting temperature of around 1500 degrees Celsius. So we can make a core material of with that thing also. But in case of steel casting or something like that, which have a melting point of 1500 or 1600 degrees Celsius, then you have to go with the course of sand material only. So you have to make the course every time with your mold. So the all three options are correct. Okay, so next one is, which of the following statement is correct? A core binder's function is to cement sand grains into the desired shape and impart sufficient strength to the cores to prevent breakage, distortion, and erosion in the core making. The action of thermoplastic binders such as resin and pitch depends on the amount of heat that liquefies and disperses the binders in the sand. So, anyone wants to answer?
I think one is correct.
Yeah, one is correct. Okay, because we have previously talked about we have to add some core binders to give it a required shape and to give provide the strength. Okay, so first is correct. Second one, I think second one is also true, because we had already talked about binders which we need to add in, such as resin and pinch, and when it comes into the heat contact, it will get converted into volatile gases, and it has to be removed from that binder surface easily. As we have talked about in this question, cores must be permeable to allow the core gases to escape easily. So these core gases are created due to this thermoplastic binders such as resin and pitch, which uh, or the volatile matter of volatile properties of these thermoplastic binders are very crucial, because when we are talking about thermoplastic binders, the conversion temperature of these binders should be always lower than the melting point of your material whichever you are going to cast in that particular mold. Okay, because if the thermoplastic binders has a temperature volatile conversion temperature of around 500 degrees Celsius, and you are going to cast a casting cast a material which has a melting point of only 400 degrees Celsius, so these binders are not going to be converted into that volatile matters, and it will create problems during your casting process. So that such as resin and pitch depends on the amount of heat that liquefies and disperses the binder in the sand. Okay, that is a major property. So the both first and second are correct options. So next one is, we will talk about CO2 molding process. Which of the following statement is correct or for carbon dioxide process based molding processes? So now we are talking about CO2 molding processes. So anyone wants to answer? So first we will talk about the CO2 molding process. In CO2 molding process, what we generally do, we use sodium silicates as a binder material. Okay. So sodium silicates as a binder material when comes into contact with the CO2 gas after we are going with the only the sand mixtures, but in sand we are going to add some sodium silicate materials. Okay, so sodium silicate when we are going to add sodium silicate material in that process and we are going to purge the CO2 gas, that sodium silicate will react with that CO2 gas and form a silica gel due to that CO2 purging, that will create some exothermic reactions and form a silica gel material that will provide the desired strength to your mold material, okay, so that it will be able to create a casting and not going to collapse during that casting process. So that is the main process. So when we are going to talk about these statements, comparative compressive strength of the sand mixtures in sodium silicate based molding process continuously increases with the amount of CO2 gas passed. So I think this is not the true one, because until a limit we can pass the CO2 gas, because that CO2 gas is going to react with sodium silicate material and going to form the going to form the silica gel. After that particular time period, if we are going to pass the if we are going to increase the CO2 gas passing, that will result in the collapse of your mold material. Okay, so that is not going to be true. Second one is the sand used in sodium silicate based molding processes must be dry and free of clay. Okay, so it must be dry and free of clay, because we are not going to add any clay. Generally, why we add clay in the sand material? Because we want the binding properties. Okay, but in this case, in the CO2 molding process, we are going to use sodium silicate as a binder material. So we are not going to use any clay. So it should be free of clay. So that is the correct one. Then mold collapsibility is better as compared to sand molding using clay as binder. So yes, this is true. We generally go for CO2 molding process because we want better mold collapsibility after your casting is finished, so that we can easily remove our casting material after that. So that will be the second and third only. Okay, so comes to next one. Which of the following statement is all correct for ferrosilicon based molding process? So this is also like your CO2 molding process only. We are going to add some particular binder material, so that is going to provide the exothermic reactions, so that we can create hardenability in that sand mold. Okay, silica sand is hardened and bonded with the reaction product obtained by the exothermic reaction between sodium silicate and ferrosilicon powder. So this is true one, because as we are talking about ferrosilicon based mold, uh, previously we were talking about CO2 molding processes. In that process, CO2 was creating that exothermic reaction between silica sand and sodium silicate powder. Here we are talking about the exothermic reaction between sodium silicate and ferrosilicon powder. So it is going to provide the silica sand its hardenability. No baking of the mold or course is necessary. Yes, it is true, because we are talking about exothermic reactions. Okay, so it will provide the necessary temperature for the hardenability. Because when we talk about that baking of the mold, we generally go for baking for the harden to get hardness of silica sand. But when we talk about sodium silicate and ferrosilicon powder, it will create an exothermic reaction and provide the desirable hardenability to our silica sand. So no baking of the mold or course is necessary. Then this is also true. As the weight ratio of ferrosilicon to sodium silicate powder is fixed in the ratio of 2.25 raised to 1 in the sodium silicate ferrosilicon based molding processes. So the correct answer will be all first, second, and third. Next one. Which of the following statement are correct for cell molding process? Anyone wants to answer?
I think 1 and 2.
Okay, 1 and 2. So I think second one is okay, but any justification for your first one?
Basically, the shell is formed with some kind of polymerizing agent, I thought.
Okay. Okay, so I think this one is incorrect, but what you are saying, the second one is okay. So when we talk about polymerizing agents are added in thermosetting resins to produce thermoplastic type characteristic, but we do not add any polymerizing agents in the thermosetting resins. When we talk about hot box molding or cold box molding, then we talk about this thermosetting type of resins. Okay, so that it can create a surface on the hot mold box and you will get your desired shape. But we generally do not add any polymerizing agents in that because that will not enhance your process. Then the second one is to accelerate the hardening action of the resin hexamethyl tetraamine is, yes, this is added for the hardening action of the resin. Then quality of resin decreases with fineness of sand used. I don't think so. That is a correct one. So only the second one is correct because that we can't say quality of resin decreases with fineness of sand used, because when we talk about this resin sand molding process, then we do not consider the fineness of sand used. Generally we consider only the resins whichever we are going to use, that will going to affect the quality of your process or the hardness of your mold whatever you are going to make. And the fluidity of that fluidity of that casting material will also depend on your quality of resin only. It will not depend on sand. So the second one is the correct. Okay. Then which of the following statement is our correct steps for hot coating sand resin mix process used in sand cell molding? Okay, heating the dry silica sand to a temperature between 200 to 250 degrees Celsius. Cooling the sand mix to about 45 degrees Celsius to prevent lump formation and to import flowability. Aerating the cooled sand mix to further improve its flowability and power to quickly form the cell. So anyone wants to answer? So when we talk about this cell molding process, uh, like consider it like this. So consider if we are trying to make this type of casting. Okay. So what we are going to do, we are going to heat a mixture of hot coating sand resin mix process used in cell. We are talking about hot coating sand resin mix process used in cell molding. So what we are going to do, we are going to create a mixture of sand and resin, and we are going to heat it so that it can easily flow on this surface. Okay, so it will create a thin coating on the surface, thin or thick, whatever the amount you want. It is going to create a coating on this surface, or we can say we are going to dip our pattern into that hot coating sand resin mix, and it will cool down on the surface. Okay, after the cooling down on the surface, what we will do, we will remove our pattern and we will get a, maybe we will get a pattern like this. Okay, so that is going to be our pattern, that is going to be the mold for our further casting process. So what we do, heating the dry silica sand to a temperature between 200 and 250 degrees Celsius, it is wrong because we generally heat it up to only 175 degrees Celsius. ठीक है, okay. Then comes to, so this is the wrong statement. Cooling the sand mix to about 45 degrees Celsius to prevent lump formation and to impart flowability. So if we are going to, so we will heat the sand resin mixture up to around 175 degrees Celsius. Then we will cool it to 45 degrees Celsius to prevent lump formation and to impart flowability. Okay. Then third one is aerating the cool sand mix to further improve its flowability and power to quickly form the cell. Yes, we will do it. We will aerate the cool sand mix to improve its flowability so that it can get in the voids of the whatever the voids are there or whatever the complex structure are there of the pattern, so it can go into that pores also. So aeration will help in improving its flowability. So answer will be second and third only. Okay. So next one is, which of the following statement is correct for hot box molding process? So anyone wants to answer? So this is basically the same process which we are talking about earlier, that cell molding process. The difference in between in that process and this process is that in that case we were going with the hot coating sand resin mix. We are heating the resin and sand mix. Okay. In this case, we are going to heat our pattern material. Okay. We are going to heat the pattern material and we are going to get a dip in the mixture of that sand resin mix. Okay. So that heating on the box material will provide the proper reaction to the salt and sand mix and it will get adhere to this surface. Okay, so the first one is correct one. The solid mass of sand mix and resin is formed over pattern. Okay, the solid mass will form here due to that hot temperature on the box on your pattern. Then the second one is the accuracy of dimension is lesser than that in the case of cell molding. That is incorrect one because the accuracy of dimension is more in this process, because whatever if we are going with like this intricate shape like this. Okay, so in these pores we are going to heat this material. Okay, we are going to heat this material, so the probability of getting the sand and resin mixture here is more in this process rather than in our previous process, because in that process the sand and resin mixture has to flow to this pattern, but in this case the box is going into that sand and resin mixture. Okay, so the accuracy of dimension will be more high, so that statement is incorrect. So the only first one is the correct one only. Which of the following statement is are correct for cold box molding process? Okay, we earlier we were talking about hot box molding process. Now we are talking about cold box molding process. The curing being done simply by passing a gaseous catalyst through the blown mass of sand. The difficulty with the process is that special equipment which is expensive is required for the blowing of the catalyst onto the core box. So anyone wants to answer? So the difference in between cold box molding and hot box molding processes is this. In that process, we are going to hot heat up our pattern. In this case, we are not going to heat up the molding material or whatever the pattern we are going to use for the molding. We are just passing a gaseous catalyst through the blown mass of sand. It is like something like as we are purging the CO2 gas. Earlier we were purging CO2 gas or we were going with the ferrosilicon process. It is like that. But for the reaction to happen, we are going to provide a gaseous catalyst to get for providing the curing on the surface of that cold box, because we are not giving any heat so that it can get hardenability. So in terms of heat, we are using gaseous catalyst through the blown mass of sand. So this one is correct. And the second one is the difficulty with the process is that special equipment which is expensive is required for blowing the catalyst. Okay, so this is true. This is the main disadvantage of this process. However, we can make any type of casting, any type of integrate or complex casting with the help of this process, cold box molding process, because we are providing the gaseous catalyst so that your sand or resin mixture can grow at any spaces required and get cured there, and you can get the desired shape of your casting. Okay, but the disadvantage is we require special equipment and for providing that gaseous catalyst flowing, and obviously those equipments are very expensive. So that is the main disadvantage of this process. So the answer will be both first and seconds are correct. So here we comes to our next question. Okay, so this is a numerical. So we are talking about a grey cast iron blocks of size 100 mm into 50 mm by 10 mm with a central spherical cavity of diameter 4 mm are sand cast. The shrinkage allowance for the pattern is 3%. The ratio of the volume of the pattern to the volume casting is. So we are talking about a mold like this pattern, grey cast iron block of size like this, which is basically uh, cubic, which is basically in cubical shape, but it is having a central spherical cavity of diameter 4 mm, which is this. We are talking about a core also. Okay, that is spherical cavity, so it will be like this. Okay, so we have to provide the ratio of volume of the pattern to the volume of casting, and we are talking about a shrinkage allowance of 3%. So try to solve it. I am giving around 3-4 minutes, so you can try to solve it, and if someone gets the answer, please let us know. Okay, anyone have got the answer? I think we will wait for one more minute. Okay, so we are talking about sand casting, which has a shrinkage allowance for the pattern around 3%, which we know it is a positive allowance in case of. Okay, so we will see. So we can see volume of casting will be volume of block minus volume of core. Okay, so when we talk about pattern, so it will be volume of pattern equal to volume of block plus allowances minus volume of core plus allowances. So that will be like this. That volume of casting will be VC equal to, so that will be around 49,000 cubic mm cube, and the volume of pattern will be, we have to add the allowances of shrinkage allowances, which is basically 3%. Then we have to calculate the VP by VC, which will comes to 1.09. Okay, so it is clear. So next comes to like question, same question.
Could you show that question 20, please?
Okay,
This
so I
4 by
think,
3 came from the formula, is it?
yeah,
Okay.
4 by 3 pi r cube is there for volume of
Yes.
that spherical cavity. We are talking
Yes.
about a spherical cavity in the center of that mold. So we have to minus that volume, because we have to find the ratio of volume of casting to the pattern. Okay, so can we go to next one?
Yes.
Okay, so this is also a numerical based on the same thing. You can try to solve it. So here we have the, this is basically the shrinkage effect which we are talking about. We are talking about a pattern of steel. Casting is made from steel. Okay, Nagan, can you switch off your microphone? Yeah, we are talking about steel. So the casting shrinkage will be 20 mm per meter. Okay, so it will be around 0.02%, I think, 20 mm per meter. So you can consider that, and you can design a pattern having a dimension of length 200 mm with 100 mm and height 80 mm. And it has a central circular hole with having 80 mm dia. So it will be like, so the casting is same, the shape is same, but in this case we have to define the dimension of that pattern. Okay, dimensions of the pattern we have to define. Earlier we were talking about volume of pattern to volume of casting ratio. In this case, we have to consider the design of pattern. So please try to calculate it, and if you can get the answer, please see. Okay, so anyone got the answer? Okay, so we are talking about designing a pattern. So just what we have to do, we have to add this. What we were talking about, we have to add this shrinkage allowance into our pattern material. Okay, So in height, we have to add height, length, and width. We have to add the casting dimensions in our pattern. That will be 81.6 mm, 204 and 102 mm. We have to add this percentage. But when we are talking about the core diameter, then we have to minus our shrinking effect. Okay, because if we are going to add it and we are going to make the core bigger, then it is going to affect our casting. So you have to keep it in mind. In during shrinkage defect, you have to add the dimensions. For the rest of pattern, it will be a positive allowance, but your core material and core pattern, it has to be a negative allowance in that shrinkage defect. If we are talking about aluminium or maybe some other material which has a positive shrinkage effect, so in that case it will be vice versa. You have to uh, subtract it from the pattern and you have to add it in your core allowance. Okay, so that thing you have to keep it in mind. Okay, for core it will be negative allowance, for rest of the pattern it will be a positive allowance when we are talking about the shrinking allowance. Okay, so that is for today. So now if you have any doubt you can ask. Okay, Priyadarshini, are you there? Yeah, Nagendra.
Yeah, see, regarding this shell molding, I
Yeah.
have been to a foundry and they are coating those shells with some kind of a light green kind of coating. That is what?
Okay.
That is thermosetting resin or something else. That's why I got confused
That
with
is that is resin actually.
that is a thermosetting resin,
That
is
is
it?
resin mixed with your sand material. They are not only coating the resin material because that will add to the cost. They are mixing the sand into that material.
No, no. After mixing the sand, they are actually coating it with some kind of green coating in the end.
Okay. If
Unfortunately, I don't have the details. Otherwise, I could have shared with you. I've noted it down somewhere. I'm unable to recall it offhand.
okay, okay, I will
Uh,
check it. I am not sure about that thing. Whatever they are quoting, I will see. We can discuss it in next
it's like light
session actually.
pista color kind of thing is there.
Okay, okay, I will see it and we can discuss your doubt in next session. Next Sunday we can discuss it. Uh, you
Yeah.
are talking about that green coating. Okay, okay. Any other doubt?
No, as of now.
Okay, okay, Naga. Thank you. Okay, Priyadarshini, are you here?
Yes, sir.
Okay, you were asking about the exam pattern. Okay, so I think that will be the same as your as you are taking, because you have to go to some offline center for your final exams. You have to go some IIT or maybe whatever the center they are giving you. You have to go there for your final exam. So the pattern will be like your usual exams, whatever you are going to uh, give you in your college. You have to write it. That will be subjective actually. In assignments, you are getting the objective questions, you are getting MCQs for your assignments, but in final exam, that will be the subjective one. Okay, so you have to write the answers. And I think in metal casting processes, there will be 50-50. I think 50% will be numericals and 50% will be theory, because there are some numericals you will uh, going to learn, maybe I think gate pattern or something, riser, blinders, binders type of thing. So there will be a lot of numerical in that portion. Okay. So I hope this clears your doubt or anything else.
Okay, sir. Thank you.
Yeah. Okay.
Exam will be for 3 hours.
Yeah, it will be for 3 hours, I think. Okay. Thank you guys. So I am going to end this session. We will meet next Sunday again. Okay. And
Yeah.
if you have any doubts, you can note them down and we can discuss them next Sunday in the
Can
next
we put
session.
it on
Okay.
the discussion forum?
I think on discussion forum, there will be other TAs which are you can put there also. There are other TAs who can answer those questions. Or
Okay.
if you don't get answers from there, you can yes, we can discuss it here. I will not be there actually on discussion forum.
Okay.
Okay, thank you,
Okay.
Nagan.
Thank you. Thank you.
Okay, thank you guys.